At Shopify is big. It's like almost 15,000 people, half of which is support. A third of the total organization is almost engineers. So you're talking about thousands of engineers. It's not as big as Microsoft, but it's also not a small, medium-sized, or large organization. It's huge. So there are some rules in place about tech stack. So almost everything should be run with Ruby on Rails and MySQL. That's your, let's say, green path. For APIs, you develop APIs using GraphQL, and that should cover most of the cases that you need. Now, your cases might be, let's say, special. You might need a bit of a performance kick. Shopify's, let's say, systems programming language was for a long time Golang, and only in the last few months it changed to Rust.
Ahmad, I'm super excited to have you with me today. I'm really excited for our conversation. One of your latest roles was a staff software engineer at Shopify. You've been exposed to a lot of interesting problems, and I'm really excited to dive deep and for us to start discussing and dissecting whatever we can about distributed systems. I think we both work in this area a little bit. We both have seen quite a bit. We have worse, what do you call them, battle scars maybe. And we have learned a thing or two, let's say, about managing some of these systems in production. So let's start by you telling us a little bit about your background. How did you end up at Shopify? What was your career like shortly as a software engineer?
Cool, yeah. Super excited to be here and talk to you, by the way. I've been following you on Twitter and social media lately. Thanks for the invitation. So my career so far, very, very traditional computer science background back in Jordan, then worked with a few startups, decided I want to travel abroad. So I went to Greece. I sold my soul to the devil for 3 years. I worked at an oil and gas corporation, very well known in the Arab world, Triple C. Did everything from like cabling, switching, networking, software development, learning against deadlines, how to be a mobile developer, not liking it, going back to web. Then I decided I want to go back to product. So I moved to Germany, joined a cool startup called Trust You. This is the brand. Yeah, at Trust You did different things, front end, back end, data engineering. And from there, I just started exploring leadership positions in with different companies. Tried consulting for a year. I learned a lot, didn't like it. I realized I don't like technical pre-sales that much. Went back to product, and I thought that at some point my career was going into engineering management. So I pursued being an engineering manager for the better part of 2 years. Learned a lot, went out of my comfort zone, but also missed being a builder. And I like that technical leadership aspect of working with other people. And that's how I became a staff developer at Shopify. I applied for it, went through a rigorous interviewing process, and then I was offered the job, and I've been doing it for since January-ish 2022. Yeah, almost 2 years.
Amazing. That's quite a diverse background, right? And it's sort of similar to mine. And my question, which I think a lot of people ask often, is did you feel ever that you lost your way by doing all sorts of different things? Or do you feel that all of these things enriched your experience and allowed you to be much more engaged and much more productive and efficient as a software engineer?
Definitely the latter. Like, I think when talking to different people before and different friends, they always criticized me trying out different things. It's like, oh, why leave the startup world in Jordan and going for an oil and gas corporate? But I learned a lot about networking, for example, and switching, very low level stuff. I didn't do much software development a lot in these 3 years. It did some, but it definitely enriched and opened my horizon, like about what I would like to do and what I don't want to do, let's say, which I would have regretted, or I wouldn't have known that I don't like doing, let's say, networking all day long, or like clipping cables and hooking them up with a main switch. It definitely enriched my experience, especially when I went into engineering management. one thing I tell people is I recommend people to try out engineering management, any engineer to try out engineering management for a couple of years. If for anything, it will make you more manageable as an engineer.
Absolutely. Yeah, I love that. Why do you think this is? Can you expand a little bit on that one?
Yeah, definitely. So I think at least for now in our industry, engineering management is going into the direction of it's focusing a lot on people. Like the staff developer role is becoming more household in different companies. If you don't have a staff role officially, you have a tech lead. So like technical leadership is slowly getting switched into this parallel track of technical leadership. So engineering management is becoming more about people, facilitating decision making, conflict resolution, in different ways. Conflict like does not have to be like a fight between different people in the team, but it could be conflicting priorities and how to really manage resourcing and budgeting. So as an engineer, you're expected to focus on the task at hand, the problem, arriving at the best solution given the constraints you have. But an engineering manager is worrying about the entire system of people working on this problem. Like who are the different people? Are the right people assigned on this project? Are they given the good chance to grow? Let's say the appropriate one to grow, the opportunities. Yeah. So it definitely broaden your perspective on, it's not just about me. It's about all these different people in the team and how my way of working is affecting other people, and how can I help my manager so that we can grow people on the team in a better way, which most of the times just mean um, you're giving this really cool project to somebody else on your team and like shadowing them as they try to make good decisions and allowing them to make mistakes sometimes if they're easy to recover from. So I think this whole perspective, which does not have to do with code and systems, debugging incidents, you have to learn as an engineering manager. Like you have a choice to learn as an engineer, but you can't dodge that bullet, if you, as sort of speak, as an engineering manager.
This is what I keep telling all of the engineers all the time, but nobody wants to listen, because this is what you just mentioned is the hard part of our work as you grow in seniority. You cannot even grow in seniority unless you learn these things. You can learn as many solutions out there about how to do data streaming, about distributed systems, about database sharding, replication, and all of that stuff. But that's not gonna let you be or get to that next level. And even when we recruit for big tech, for example, this knowledge of these systems, they only look for certain things or a certain level of depth, but they don't expect you to literally know everything about distributors and come fully prepared, because they know you're going to be learning all of this stuff on the job. But what's more important, especially at staff plus levels, is how do you deal with complexity? How do you deal with others? How do you optimize for building these systems for them to perform well? How do you work with others so that they can perform at their best ability as well? A big part of my job also is to also help enable the rest of the team, make them more efficient, more productive. You might say this is the manager's job. Yes and no. I look at the staff plus engineer as a counterpart for a people manager, right? A partner. My relationship with my manager right now is for more of a partnership than anything else. We talk about together how we can make the team better, more performant, so on and so forth.
Yeah,
I think
100%. I think like if you ask like what kind of activities have to happen in a team for it to be successful, like you have to care about, let's say, the people and how the people work, which are processes, then the projects they work on, then ultimately technology, right? And strategy moving forward. So I think the staff engineer, as you said, and the engineering manager, like they care about the same things, but with different priorities. So I would expect the engineering manager, at least at this stage of my career, I don't know everything, is that the engineering manager would care a lot about people, processes, projects, and tech in that order. And the staff engineer would worry about, or let's say care more about tech, then projects, then processes, then people. But they still care about the same things.
Love it. That's a nice way of putting it. All right, let's switch gears a little bit because we're going to come back to this and talk about it more in depth. But I want to talk about some of the interesting problems you tackled while working maybe at Shopify or while dealing with systems at scale. Is there something that just jumps to mind right away? Something that you can, talk a little bit more about and expand on an interesting problem you solved, an interesting challenge that can give us a new perspective into dealing with these types of systems.
Yeah. Like so many things come to my mind, like very open-ended question. So
Pick
maybe we
one.
can, yeah. So most recently at Shopify, I was working on a problem called eligibility, like merchant eligibility. So at Shopify, I work as part of the Shop marketplace. Shop is a mobile app built by Shopify on Android and iOS, and it's like eBay, Etsy, and Amazon. All the merchants, the kick or like what's special about it is that all the merchants on Shop are Shopify merchants. So if you open a store, you'll be on the marketplace if you go through a sign up process. And the problem is like, how do you decide which merchants should be on the app and which merchants shouldn't be on the app? Like from an eligibility perspective, right? And this is like I think the age old question of quality. Like, how do you ensure what's a good player in a marketplace, right? Like, well, how do you define good behavior? Like, you can talk about fraud, right? Like, not fulfilling orders would be fraudulent. Like, you're getting orders from people, but you're not fulfilling them, or you're charging people, but you're not sending them orders. These problems are easier to solve at Shopify scale because it's been in e-commerce for a long time. But when you open a marketplace, it's different. And the nature of the problem was tricky is because Shopify always cared about merchants and not buyers because it's an e-commerce platform. But Shop, we own the buyer experience. So we're responsible for people now, the buyers, not just the merchants. So we've been trying to come up with a list of like a checklist to what would be a good merchant behavior. And historically speaking, this has evolved to be about search, about discovery of products. So everything is phrased within like, oh, do you want to be on the Shop app? Oh, you can. Okay, sure. So now that you're on the Shop app, please enable this payment gateway, Shopify payments, whatever. Like 2 or 3 steps, and that's it. But as the marketplace evolved and it grew, and then COVID hit and people started selling masks, and then you had these regional, let's say, regulations. It's allowed to sell masks in some parts of the world, but it's not allowed to sell masks in Europe. So how do you deal with all of this different regulations in different geographical regions, but while at the same time building a single system that can cater for all of these people?
And how would you approach a problem like that? Like, I love that you described it from that's the business problem, right? We have a business, we have a problem we need to tackle, and that's honestly the what we will be tackling as staff plus engineers. People think that, oh, we're gonna get a requirements list from a product manager. Wrong. That's not how it works. Working with a product manager, for example, or a product owner or whatever it is, the product owner understands the business problem more than anyone else, supposedly. They care about how the business is going to perform in the future. What are some of the business challenges we're going to be tackling in the future? They might have some insight into the technicality of it, which is great to understand the boundaries and the framing of the problem. But this is where we come in as staff plus engineers in the design process of the solution. So what I'm really curious about is, how would you tackle such a thing? Is it more of a role-based solution, for example, or do you create a policy management system, or is there some other interesting way? Does machine learning come into play? I'm pretty sure here's some data, machine learning, behavioral analysis comes into play. So how do you come up with the solution, and how do you zoom in to make that solution dissectable enough so that engineering teams can actually start picking things up and working with them?
That's a great question, because it's exactly what the role is about, right? Like, you're given a problem by leadership and they say, we don't know how to solve it, go figure it out. And you say, I don't know how to solve it, but I'll try to figure it out, essentially. So the problem predated me joining Shopify and Shop. So there was a little bit of a solution, but it was not really hassle-free. It was a batch processing pipeline written on Apache Spark and Python. It runs once a day. And it takes up to 48 hours to decide if a merchant is eligible or not. Now, that's a problem. It's a problem because if you're a bad actor, you have 2 free days to do bad things on the marketplace. Or if you're a good actor, it will take us 2 days to put you on the marketplace. You could be frustrated, and as a business owner, a store owner, you could say, I don't want this. I'll just go with a competitor. So like the true positives and the true negatives are bad for business in this case. So what we try to do is, like, first of all, map the system. When I joined, the people who built that system have moved on to different teams, so there was like a lot of tribal knowledge hidden in code. Reverse engineer it.
The worst.
Yeah. And then it took us 3 months to reverse engineer the systems, and then we said the following. We said the problem with the current state of eligibility is that there are too many rules. Like, we need to simplify them. So like and the rules are online. We can talk about them. They're on the help center. It's like you have to enable a payment gateway. You have to enable a payment wallet. You have to your store should not be password protected. People should access. It should be accessible. You should not be selling these prohibited products, and so on and so forth. And as a merchant, you go through a huge checklist, and then later on to discover an edge case. So we started simplifying them. So one way we simplified it is we said, like, do we really have to make merchants wait 90 days by charging clients on their Shopify store before they actually get on the marketplace? Do we have to do that? That was like a rule decided on a long time ago. And the reason, and then it's like it's like Chesterton, I forgot the name, Chesterton's fence. I think it's like if you find a fence somewhere, like as a barrier between a property or a land, you could say, like, oh, is this needed? Like, I could just remove it. I could just remove this fence, and it won't change anything because it's empty land. I'm probably butchering the mental model here, but we can link to it. And it's like you ask yourself, like, if I remove this rule, what would it break, right? And then what we discovered through reverse engineering through the org is that, oh, it was just a proxy for people to know that, yeah, as a merchant, you charge people once, and we have to wait 90 days to make sure you're a good actor. But that didn't actually prevent people from being bad actors. Like, you could start a Shopify store now. I'm probably giving people bad ideas, but like
maybe we shouldn't dive into that.
Yeah, like, but you could game the system. Like, any system is gameable, right? So
Absolutely.
it's like, so what that rule is doing is it's making good people frustrated, or good actors frustrated on the marketplace. So we removed it. We went back to the payment transactions. We removed a lot of rules about enabling and disabling payment transactions. We just check when you sign up if you enable the wallet or not, and like 2-3 other rules, so laws. So what we started doing is probably like a poor man's domain-driven design of some sort, like against a deadline, I guess. It's like, here are all the rules. What is the mental model? What are you trying to model with this? And what you're trying to model is something really incoherent and inconsistent. We removed all the rules, and we just came up with one definition. Eligibility is when the business says you can sell on the marketplace. Remove this bad actor, good actor thing. And opt-in is when you say, I wanna sell. So you're on the app if you say, I want to sell and I'm eligible. And you're eligible if your chargeback rate is less than 1% and you have a payment transaction, like a payment gateway, and that's it. We went from 10, 12 rules down to 2, 3 that you can check out. That's like a checkbox that you can check off in your first, that you can take in your first, let's say, a few hours of enabling the marketplace.
Amazing. Tell me a little bit more about some of the landscape that you were dealing with. Were you dealing with a service-oriented architecture? Was it more microservices? And again, I know that some of these details cannot be made public, but as much as we can talk about this, or was there a consistency in the technology stack? Because one of the biggest misconceptions that people have about a lot of the different companies that work in tech is that some of the popular ones have a unified tech stack. Everything is figured out. Everything is consistent, so on and so forth. But that's rarely the case. Different groups, different teams, different organizations, they use different programming languages, different frameworks, maybe even built in-house, frameworks that were built in-house to solve different types of problems. Can you talk a little bit more about the consistency of the landscape?
Yeah. That's cool. And I think it also touches on the previous problem and how we solved it. So at Shopify is big. It's like almost 15,000 people, half of which is support, a third of the total organization is almost engineers. So you're talking about thousands of engineers. It's not as big as Microsoft, but it's also not a small, medium-sized, or large organization. It's huge. So there are some rules in place about tech stack. So almost everything should be run with Ruby on Rails and MySQL. That's your, let's say, green path. For APIs, you develop APIs using GraphQL, and that should cover most of the cases that you need. Now, your cases might be, let's say, special. You might need a bit of a performance kick. Shopify's, let's say, systems programming language was for a long time Golang, and only in the last few months it changed to Rust.
That's an interesting topic to dig into.
That's an interesting segue. Yeah.
Yeah.
For like so is it microservices? Not really. There are some repos that are small enough to qualify as a microservice, but because, like, you might know already from the Ruby on Rails community, you don't just decompose monoliths, you just get used to them. So you start like a service, and it just grows. So my organization, the Shop Marketplace, is one big monolith. Shopify core, when you go like sign up on Shopify and start your own store, that's a big monolith. And there are like a few other ones. So the core Shopify business is spread around, like, let's say 5 to 6 monoliths of some sort. So how do these services and APIs communicate? Through APIs and with their tech stack of like circuit breaking and SDKs. But the more common one is actually message passing over Kafka. So Shopify runs a lot of Kafka clusters regionally within Europe and the US. And it's just a very ubiquitous thing to, if you have an API or a system, you start a topic, you create it in different regions, Canada, US, Europe, and then you start sending messages to it. And the cool thing about it is that it gets replicated between regions. So like you can have consumers in the States and consumers in Europe. So people who are interested in your system and what your system is doing can just subscribe to your Kafka topic and read the messages. And that was one of the solutions. Like how we tackle this eligibility problem is, like, one way to make eligibility a bit more streamlined is to ask yourself the question, do we really need to go back to this huge data pipeline that runs once a day and takes up to 48 hours for the message to really transport to us and make sure that this merchant is eligible, that merchant is not eligible? And the answer was no, because like when you take a look at the signals that we were really interested in, do you have your store password protected or not? So that's a Boolean flag. Have you enabled the payment gateway or not? That's another Boolean flag. Calculating chargeback rate. Chargeback rate is when you go, let's say, I don't know, to adidas.com, buy a pair of Adidas shoes, you get it, you don't like them, you charge back on your credit card, for example, and you return the product. When you charge back on your credit card, we get that because every merchant on the marketplace has the Shopify payments gateway. So we know when people charge back on their credit cards. So yeah, that has to be computed within like a certain time frame. So that stay within the data pipeline. And we took all these other Boolean signals, went back to their source systems and started lobbying people. It's like, hey, you're this team, your system does the password protection thing. Can you please give me an event? Sometimes we found that event. Sometimes we didn't find it. And we just paired with that team, introduced that new event. So every time they change something, we get like a change data capture,
right,
capture the event,
and then you would deal with it.
Exactly, and we consume it. So that took eligibility down from 48 hours as like an end-to-end latency to come up with a solution, to come up with a conclusion, down to 32 seconds.
Wow. Amazing. All right. So I have a lot of questions because I want to dive deeper into this and talk about some of the problems you might face with this event-driven architecture. So basically, just to summarize, you have a bunch of monoliths that are your 4, 5, 6 services, whatever the number is, and they are integrated via Kafka. And basically each service, when it wants to communicate something, it just emits a message. It goes into Kafka, and whoever needs that message can just pull it and subscribe to a topic and act on that message whenever that message becomes available. Now, the question becomes, what happens when you need the response from that other service as a response to the message that service A has emitted, for example? How do you deal with that? Can you implement transactionality in an event-driven architecture? And if not, what's the alternative to this?
Nice. Great question. So if you really need a response, it depends on like what you're going to do with that response. If you're trying to build a business process, most probably you'll build it using different APIs with like levels of redundancy in them. Like that's how, on a high level, that's how checkout at Shopify works. You have a lot of products you try to check out. Shopify begins, let's say, the payment transaction. It prepares the payment service. The payment service says, "Yeah, I'm prepared. Let's go." It submits the transaction. You're waiting, right? You're waiting for these like a few seconds on the checkout page. And once that dance between the payment gateway and the checkout service is done, an order gets committed, confirmed, it's charged, and you either get a confirmation on the checkout or everything is rolled back. So that dance is done using mostly APIs. So if you need a response and it's critical, you just go with the API
REST APIs
integration.
or gRPC
No,
or RPC?
they're Ruby APIs.
Okay.
And these Ruby APIs were done mostly on GraphQL. So you're doing GraphQL mutations.
GraphQL, right.
Right. And then the state is persisted on most probably a MySQL database.
Interesting. Okay, so for certain types of problems, you actually rely on just GraphQL APIs to do certain mutations, and you block until you get your response, and then you act on that. Cool. Kafka and events. You mentioned geo-replication. How do you deal with replication latency? How do you deal with certain events popping up somewhere but not somewhere else due to replication lag, and all of these? How do you manage a geographically distributed Kafka landscape?
Right. That's deep. So I didn't work on the infrastructure team, but I knew about infrastructure a little bit. So I'll try to do my best. High level. So high level is Shopify always had its own, let's say, Kafka clusters on VMs, and when we moved to the Google Cloud, which happened the last couple of years, these VMs started running on Kubernetes as stateful sets and containers. So what usually happens is to replicate between geographical locations. It depends on the data and whether it has PIIs or not. Like you can imagine, if you have a store in Europe, you won't be replicating orders and payment information over to the US. But what you would see get replicated is settings. For example, you go to your store and you enable or disable a payment gateway that gets sent over Kafka and replicated, for instance. And what happens is you just I think what the architecture is that there's a controller for like a Kafka topic. There's a controller for that, and that controller decides like which are the different brokers, geographically speaking. The main writer, or let's say the main primary node, that becomes the node for your topics, and then the other ones just get replicated as if they're on the same cluster in the US, but you treat also Europe as part of that. So replication is just happens as part of your, let's say, Kafka cluster configuration.
Right.
But like this is like the super high level.
Got it. And also because I think it's event driven, then replication lag is not that big of a deal, because the services will only act when that event becomes available, as opposed to, for example, pulling information from a replicated, database, for example, where if that information is not available in the replica, then the pulling has to continuously keep on happening, and then there's a lot of nasty cases that could happen as a consequence of that. Some of which we deal with at GitHub. And one of our biggest, at least in my opinion, pain is using MySQL. Do you have any thoughts on the usage of MySQL in a high availability environment with a lot of replication requirements? Do you feel that there are better relational databases that can do this at scale better than MySQL, or do you think MySQL is a fine option?
Good question. So I think about replication, what you just mentioned is we noticed, and we'll jump into MySQL because it's like related. What we noticed is Kafka is very fast at replicating data and publishing and subscribing and consuming from it. So what we saw, the replication lag is in either MySQL itself or the Ruby consumers of Kafka. So basically, Kafka doesn't care. Like we stress tested in one project, publishing 1 billion events to Kafka, and it happened in like a couple seconds. But like consuming the 1 billion events from a Ruby consumer, even when you have multiple replicas of that consumer, it took forever almost, because you're doing business logic and you're dealing with the Ruby runtime, and that's an interpreted language. Yeah. So Kafka is not the problem. The problem is the technology consuming from it. So two things about MySQL. What Shopify did to replicate MySQL is there's like a baked solution within Shopify. It depends on the bin log, MySQL's binary logical replication. So any changes to so databases that need replication, a bin log would be configured for them in terms of like, okay, so you're replicating your data over to Kafka because that's essentially the problem. And what happens is it's called CDC pipelines, and the change data capture streams that changes from the MySQL database over to a Kafka message, a Kafka topic, and that Kafka topic has the same name of the table. So if you want to see what's happening on that table, you just subscribe to that Kafka, and the messages in that Kafka are Avro serialized, so they're binary serialized with their own schema. So you see the field names and you see everything else. That may not always be possible because, again, PII data. So some tables may not have that kind of replication. And regardless if there is PII data or not, due to also GDPR compliance reasons, you may not always have the before change. So you always have the after change, for example.
Interesting. So with this setup, you could have like a primary, MySQL database which you write to, and then that information gets replicated to like one or more replicas, I'm assuming.
Correct.
And then your application or service is configured to read either from the replicas or fall back on the primary whenever the replicas are not really available.
Yes. So that's the MySQL setup itself, like read replicas and a write primary. So if you want to read from MySQL, most probably you're going to hit a read replica. If you want to write to it, you'll go to the primary. And if your service, if your like Ruby service or Golang service is interested in what's happening with that table, because maybe that's a configuration table, you don't have to hit an API. You just talk to, let's say, a Kafka topic, and the Kafka topic will have the data changes streamed from that table. Yeah.
So that brings a question to my mind. How do you deal with migrations and database schema changes? That must be like a tricky thing to solve. Or do you avoid it, or do you bite the pain and deal with it? How do you deal with it?
That's a great question. So the solution differs based on the database you use at Shopify. So Shopify internally has Kate SQL. I think it's open source, probably. Yeah, it looks like it. No, I don't know. So basically, Shopify has its own, let's say, Cloud SQL GCP alternative, which is cheaper. It's a MySQL VM with like a nice console. So that's a solution. Some teams, because of like Kate SQL does not give them, let's say, the scalability, does not fulfill the scalability requirements. They go with Cloud SQL and GCP. And then some people go with Bigtable, especially if you're in data land, for example, you store things in Bigtable. So schema migrations are different. But let's say MySQL, what would happen is we run LHM migrations, migrations. Online schema migrations. That's an open source tool. I think what it does is, so it's a zero downtime database migration. What it does is, I think it elects a new primary. It locks the primary, migrates it, moves all traffic to primary, then migrates the other ones, and then does conflict resolution. Awesome. But I might be butchering how LHM works, but I think
that's okay. We got the gist of it.
One thing that's interesting to mention is like scaling MySQL, right? Which is always hard. So you can, if you go down the route of microservices with MySQL at scale, it will be painful, in my opinion. So if you have a microservice approach, let's say you have a booking service, right? And you want to book apples, for example. And if all traffic from your systems to book apples goes through that microservice, and that microservice is powered by MySQL, and then you have booking, and then you have inventory services, and you're going with like the buy the book microservice architecture, and you're trying to do distributed transactions. That's like, I think, a short way to go to hell, probably. Like for you will be living in hell. So what the Shopify way of doing things is, they said, look, we don't want distributed transactions and distributed locking. What we're going to do is we're going to shard the whole architecture per shop. So as a store, if you go to production, there is something called the Shopify pod, and there are a lot of cool articles on the Shopify engineering blog about it. What happens is Shopify does not really shard the system by function like microservices, but it shards them by shop and product and so on.
So by
So
tenant.
by tenant, exactly. So every Shopify merchant has a MySQL database, a Redis instance, and a meme cached instance assigned to them, and a cron job, let's say a Ruby cron for them, a cron tab. What they share are the background workers and the list of Nginx load balances. But every tenant has their own, has their fully functioning Shopify. Like you would
Yeah,
clone the
it's like a
whole
small scale
ecosystem.
unit,
It's a
which you
small scale
replicate
Shopify.
per
Yeah,
merchant. Yeah.
exactly. And then that's called the Shopify pod. Basically, when you have like a small scale Shopify, that's called, it's not a Kubernetes pod, it's a Shopify pod. And that Shopify pod could host one Shopify tenant, or 3 or 5 or 10, like small ones. And as they start growing in size and resources, you'll start having this noisy neighbor problem. There are background services that just keep checking the resource allocation and access patterns per shop. And when they see that a shop is becoming bigger, they just move it to its own pod. And it keeps going from there.
Let's explain the noisy neighbor problem a little bit.
Yeah. The noisy neighbor problem. Let's assume that you have a one server and let's say 10 users on it. And they all use, these 10 users are using 10% of the resources. So you have 100% usage. But then one user starts growing a bit more. So they start needing 20%. So now your server has to allocate 120% of work, let's say, using 100% of resources. And that starts affecting the other users because you're chewing requests from them, you're chewing CPU, memory, disk usage. Yeah. And like services becoming lagging, you start seeing latency problems or storage issues. So that's the noisy neighbor problem. So what you do is you take that noisy neighbor, that big user that just scaled, move it to its own VM. It's 20%. And now what you're left with is 90% VM, the original one. And people can use it, let's say freely. They have like some wiggle room in terms of resources.
Is each Shopify pod a VM all by its own, or is it some other, or is it a combination of VMs, for example? Or because my question is going to be, how do you guarantee isolation? So noisy neighbor could be on the resource consumption level, but there's also a security component to this, where someone could break out of their pod, for example, in some way or another, and then you could jeopardize the data and information of another tenant.
Right. So isolation is done at traffic and hosting level. So there is routing information about where every Shopify URL, which is like the store, is stored, right? So let's say basim.io is stored on pod 1. Ahmad.io is stored on pod 2. So all traffic gets routed there, all writes, all reads. Not only that, but when all writes and all reads, well, that's everything almost, right? Now, you take front-end caching out of the picture. Front-end caching is cached with CDN all over the world. So if you're accessing a web page, you're probably going to hit a cache and not the server. So you only go to the server to store if you're going with APIs, basically, and data access, and so on. And traditionally, these were Shopify VMs, basically VMs before Google Cloud. They were like just a bunch of VMs, big arrays of VMs all over the world, in two primary locations like Europe and the States. And what would happen is, in addition to the traffic routing, you will also have pod assignment, let's say, like where does the store live? Like that's your permanent place until you get moved, unless you get moved. When Shopify started moving to the cloud, some of them were moved to VMs. It's like it was an ongoing process. Some of them were moved to Kubernetes. The end goal was to move them 100% to Kubernetes. So you can think of them as like namespaces. And within the namespaces, you have a pod, and the pod has a bunch of containers, and that would be the specific merchant, let's say.
All right, so you mentioned caching. So the front-end caching happens through CDNs, as you mentioned, which is great. And for the folks who don't know, CDNs are content distribution networks. You could use your cloud provider for having a store like that. That's fine and easy. But what about database call caching, for example, if you're retrieving database information? So with your pod setup, that is because you have a multi-tenant setup, you have a centralized caching solution, you have a cache per tenant. How do you deal with this problem?
So that's a good question. So there is a cache per tenant. So every pod has its own isolated cache, because when you're going to hit that pod, you are hitting an entire store. So anything after that store, the store's products, the collections, images, everything you besides like static assets, you're hitting that tenant's cache. Now with our marketplace solution, because we were not hosting the tenants anymore. The tenants we just get from Shopify via APIs, and these tenants are hosted in their own pods. So now we moved into a service integration on the apps, let's say the mobile apps side, and for that we cache centrally for the marketplace, and we cache APIs essentially. So because we use GraphQL for everything on the mobile app and the backend, so it's easier to see if you're hitting the same request or not. You're accessing the same GraphQL query with the same parameters essentially, and we just cache it for. It depends on the use case really, but it can be cached from 5 minutes all the way to 30 minutes.
Brilliant. How did you find, so GraphQL, were you using it only to expose APIs to internal clients or services, or also for external clients as in browser and mobile app? You were using it all the way?
Yes, indeed. So if you go to Shopify Dev, which is basically the development environment for Shopify, like you can, so Shopify has an app store, right? So you can develop apps for merchants. It's like WordPress plugins, but on steroids. And you do that by using the Shopify development environment, the SDK plus the GraphQL API. So all the APIs there are GraphQL.
Amazing. How did you find, how was your experience with GraphQL? I remember, at GitHub, we use GraphQL internally, but then we decided that we don't want to maintain it internally and we relied on something else, but we still maintain the public GraphQL APIs. How's your experience with GraphQL for in-service communication? Let's put it that way.
So it was my first experience developing GraphQL APIs on scale. Before that, it was like in smaller startups, so you can pick and choose, like, oh, this is a REST API, that's a GraphQL API. But when you go all the way, you start seeing the limitations of the technology. One of them is like boilerplating. So if you're going to roll out your own another GraphQL API or a GraphQL controller, you have to do a lot of the same work almost. Like Ruby allows you to do like extending your class with different other classes to get authorization, authentication, but still the access patterns are going to be almost the same. It's either a query or a mutation. And Shopify's philosophy of developing GraphQL APIs is that everything is on the back end. So you can customize your query on the front end, but everything will be implemented on the back end. So there's no dynamic query parsing. All the queries are already implemented, and we generate an SDK, a schema for the front end, and that's how we use it, essentially. So it's like a very strict OpenAI specification for a RESTful API.
Sounds good. I like that. And I like the idea of being able to generate clients based on the specification you have, and then the other application that needs to integrate or call these APIs simply integrates through the client, which makes everything much more streamlined. But then comes the problem of versioning and making sure that you have the client that is relevant and up to date, so on and so forth. So how do you deal with that? Do you package your clients and publish them in an internal package registry of sorts, and then people pull the version they need? And then how do you deal with deprecating certain APIs, for example, or documentation, or all of these things that come with this approach?
Awesome. So every breaking change to an API has to have a new. So we use semantic versioning essentially. So if it's a small patch, that's a minor version. There's a minor, micro, and then major. If it's a breaking change, that's a major version, and it goes through a release cycle. If the API you're deprecating is used, let's say by the mobile app like Marketplace, it has 1 year deprecation cycle. If it's not inter-service communication, inter-services, we use the latest, which is like unversioned version of the API. So that's like cutting edge. Any change you do to the API gets versioned twice. So the semantic version plus the unversioned one. So that's like the latest cutting edge. And services just use the unversioned one.
Oh, interesting.
I can't generalize.
Is it a nightly build?
No, if I change the API now and I release the API, the GraphQL API, it's part of the unversion version. Like let's call it, let's say, cutting edge version.
But doesn't that break things? Like, let's say I'm relying on one of your APIs, you break it, and I'm pulling your unversioned client, and I'm using it internally. Doesn't that cause problems on my end?
True, which is a problem that you have a free fix for when you use monoliths. Is once you change your own API, and everything is a monolith, including the mobile apps backend, tests are going to break, and you either refactor them or you request changes from other teams.
Love it. For people listening in, this is why people stick to monoliths.
With monoliths,
Yeah,
yes.
it's just much, much easier than having to deal with all of these problems. Because with services in general and microservices, to be more specific, problems like this, they amplify exponentially.
Indeed.
The amount of time you need to maintain these versions, incompatibilities, so on and so forth, mushrooms in size. And then what's worse is if you don't want to deal with that, then you have to guarantee backward compatibility for years to come.
True.
And that also halts your progress and your ability to make faster changes.
Right. And just for like intellectual transparency, let's say, so Shopify core, like the core organization which builds the platform, goes through a rigorous release cycle of GraphQL APIs, right? And then public clients have, like, they can't use the unversioned version, like publicly outside Shopify. They have to use a specific version, right? So that's the outside world. The inside world is you get to pick and choose. You choose a version or you choose the unversioned one. So that's your choice as a developer. So in the marketplace, we always integrated with the core APIs unversioned. When they get released, we immediately know. And I think you can call it like an organizational hack rather than having meetings and discussing release notes. Your tests are going to break.
Yeah,
essentially.
love it. But that also requires a lot of discipline around testing. So
True.
Let's talk about testing since we're already there. Unit tests, integration tests, end-to-end tests. What's your flavor? What's your poison?
All of them.
To what extent?
To what extent?
How do you make the decision how far you want to go, right?
True.
I see a lot of organizations fight over coverage, which in my opinion is complete bullshit. I see a lot of organizations, they are like the Wild West, which is pretty inconsistent across different services. Some services are very well tested, some services are not. And some of the services that really need testing don't have it. So how far do you go towards implementing a culture of testing?
Right.
Automated testing.
Right. Yeah. I think some open source communities have it better than others, I think. Ruby on Rails, like Rails basically advertised and almost like indoctrinated people into writing tests, which I think is good. Like you get, like if you have a Ruby on Rails developer, they've read a book, they've been working a couple months with it, they know that they have to write tests if they're working with a Ruby team or a Rails team, let's say. So that was easy. Before Ruby on Rails, I came from a Python shop, which is like the company at Trust You a few companies ago. And I was the first one to introduce testing, which was crazy. And it was a big, big challenge to introduce testing. And like one of the common pushbacks you get from people is like, aren't you wasting time with like testing? I kept like pushing for it. I was adamant about it. And then at some point, my team built an API integration platform with Booking.com and TripAdvisor. It's like hospitality stuff, creating hotels and exchanging reservations. And we reached a point where we did not do a single user acceptance test for our API. Everything, like we had almost 80-something% unit test coverage, and we had end-to-end tests for our APIs based on open API specifications, all automated using Python. If we change the schema, we know if the tests pass, they're going to pass for our clients. And we had like 0 incidents with that. So I think what's my take on tests? Do all of them. Like people can push a lot of tests that are meaningless. I agree, and there is really no easy cut answer for this. I think that it's more art than science, and I think you yeah, you get like a good amount of tests from asking other people if they think they're confident shipping this code just by looking at the tests.
Yeah, absolutely. That's the razor's, the Occam's razor. Are you confident shipping this with the amount of tests you have right now, or do you feel there are scenarios that might break that are not covered by tests? And if that's the case, you should implement the tests. Not coverage, not 90%, not 80%. This metric is a vanity metric, and it means absolutely nothing.
True.
What matters is your confidence level, and I really like this. All right. So a lot of people complain that tests require or add a ton of maintenance. So we implement them, great. Then we want to make a change. We have a lot of rewriting to do or a lot of changing to do. Sometimes also it makes refactoring even harder. What's your philosophy around the complexity of the tests? Because a lot of people preach that tests should not be totally, or at least the TDD folks, test-driven development folks, preach that unit tests should not be coupled with the implementation details. They should test for certain scenarios and certain cases, but they don't necessarily need to be aware of how you implemented a certain function or a method or whatever. What are your thoughts on this? How do you approach unit testing? What's the level of complexity? When do you know that this unit test needs to become an integration test, for example?
Yeah, I've been thinking about this a lot, and I don't know. I don't have a single answer. Like some cases, I think tests should know about the implementation detail, especially if you're like testing a specific way of doing things, like database access patterns, for example. I don't want any implementation to pass because maybe, for example, I'm building a Kafka consumer, and this Kafka consumer is going to consume messages that get published over Kafka in a burst, a spike, billion events. So if that consumer just stores things in the database and that's the test, that's all fun and dandy. But what if your implementation has 13 database queries instead of 3, for example? Both are implementations, right? But one is like both of them are also different, and both of them are going to mean differently when you ship them to production. So, but at the same time, I can't really generalize this rule. Like testing is really hard. Testing is like, again, the age-old question of quality. What is good quality, right? So I think if I'm going to say, let's say this, rather than coming up with rules, how about we come up with guiding principles, right? A test should, let's say, test for the input-output, right? If I give you this input, you give me that output. If there's a side effect, like you're touching another API or a database, I should also be testing for the side effects that they're happening in a certain way. Let's say that. So if your function is pure, I just give you an array and you return a dictionary, whatever. That's easy. But if your function goes to an API, a unit test would mock that API, but there should be an integration test to make sure that if the API fails, that I can handle that failure, because that's another branch, right? If I go to the database, what if the database is away? What if the database is down? What if it's going through a replication lag? Does it hit another read replica? Do I queue writes? Do the writes get queued? Like there are all like first, second, third order effects that happen when you have side effects. And I don't like rules because like there's always exceptions. So what about guiding principles? I think the conversation around tests could be a bit less religious,
Dogmatic, yeah.
Dogmatic, exactly, and a bit more flexible.
That's the 100%. That's the problem. The other day, someone came in and wrote a comment on one of my TikToks. They're like, you always talk about software engineering in a very heuristic form. You never give, very specific details. You never talk about very specific scenarios and how to do things. And then they asked for my GitHub profile. I shared it with them in the comment with a very open spirit. And they're like, oh yeah, that makes sense. You have no hard skills. So obviously you talk about software engineering from a heuristic form because you don't have the skills to talk about the technical implementation details. And I sat down thinking about this comment and try to figure out where is it really coming from, why are people so adamant about them being fed a specific recipe for doing things?
Yeah.
I want to talk about fucking mental models. I want to talk about how you could reason about software engineering. I don't want to teach recipes. That's not my business. And I'm not in that area, to tell people how to do it, because it's an art. You don't teach art, right? You teach some techniques, which is fine. Everybody in software engineering should learn some of the fundamental techniques, learn how to do unit testing. That's great. But how far do you take unit testing? That's the art. That comes with experience. I'd rather talk about mental models, just like you did right now, which is fantastic, guiding principles, as opposed to do this, get to this metric, do that, get to this point, which is complete and utter bullshit.
Yeah.
And I can understand that junior engineers want this formulaic approach to software engineering because they feel lost, or they need to create like a sort of a paved path for themselves to be able to go to the next step. They want milestones, so on and so forth. But my friends, this doesn't come easy. This is why this craft is difficult, because of all of the uncertainty that comes with it, because of the complexity of the variables that we have to deal with. And the sooner you learn how to deal with the uncertainty, the better engineers you will become.
Indeed.
I'm pretty sure you, Ahmad, myself included, we are very comfortable with not knowing everything. We have gotten to a point where we have dealt with so many problems, so many systems, so many whatever, that we understand that there will be problems that we, first of all, cannot think about. There will be problems that we can never anticipate. There will be problems that we never can design for. So we will do our best, and that we have to be adaptive enough to tackle the uncertainty that will inevitably come and we have to deal with.
Yep.
Sorry, this went on a small rant, but I just wanted to make this idea pretty clear for everybody.
I agree with everything you said, and I think that it essentially boils down to uncertainty. And I think I think what doesn't get talked about, and this is something that I think becoming an engineering manager might help an engineer, is like trying to see the social aspect of the craft. Like programming is as mathematical and logical as it is a social endeavor, right? Like if you're gonna build any system worth building and worth consuming by other people, you're gonna build it with other people too. The reason pair programming is good once you like anything in your life, if you're gonna pick it for the first time, it's gonna suck and you're gonna hate it. But once you make it work, you're gonna love it. And the reason you're gonna love it is it makes everything faster. Because it's a social endeavor, not just because it's social, because there are so many benefits of like trying to tweak how systems build from a social perspective. Like a faster learning curve, you get early feedback on your thought process as an engineer from another engineer. It makes pull requests and code reviews faster. It makes you identify bottlenecks or essential, let's say, dragons, caves in the code much earlier. All of these things are social, and I think complexity is one of them, right? Like you don't have to you don't have to know everything, because not everything is relevant. You just have to know about the risks, and the risks are a small subset of everything you're uncertain of.
Here's my mental model about software engineering after spending more than 15 years writing code in all sorts of ways, shapes, or form. It's fundamentally an optimization problem, right? We have to converge on either a local maximum or a global maximum. People who don't understand what an optimization problem is, people who don't understand the gradient descent algorithm will not understand this analogy. But software engineering is pretty much fundamentally this. The more experience we have, the faster we can converge on the appropriate solution. The faster we can direct ourselves and nudge ourselves in the direction that will get us to that local maximum or that global maximum, right? The only time when we can hit that point or we can hit that maximum from a single try is when we are redoing something exactly the same way as we did before. And these cases or these scenarios are very rare and very far in between. And even with these cases, there will be variables that are gonna make the problem, the optimization problem, different than the one we've seen before. So if we approach software engineering as we are trying to converge towards a solution, We don't know what is the right path. We just have to keep on iterating, nudge ourselves in different directions until we get to that, solution that will work. And then we have to keep on iterating on that solution to get from the local maximum to the global maximum. And I would really wish people would understand this analogy, because then it just sort of unpacks everything we keep on talking about in this field.
Yeah, 100%. It's like you shouldn't strive to get it right the first time. You should like adopt a more heuristic evolutionary approach to it, like going from one local maxima, like closer to global maxima. Like if you hit it the first time, it's awesome. But like don't get frustrated if you don't know the path there. And this like it's getting very wishy-washy, but I think it is wishy-washy because essentially you're most probably like as you develop as an engineer and you start taking on more technical leadership, you're going to get handed problems that are unshaped yet, right? Like the way I think about it is like imagine it in different levels, right? Like you have the intern or the junior engineer and they get handed a very well-defined task. Do this for that reason, and this is the outcome. And you get a mid-level engineer and they require less hand-holding. Then you get a senior engineer, and that's a big deal. So these are your subject matter experts in the team, right? They possibly could shape up work for other engineers, but the PM has already done the shaping. Now, as you get like tech lead or staff and above, you get involved with the same conversation the same time that a product manager or a product lead gets like hears about it for the first time.
Right.
And they say, build us an Amazon Prime competition.
Yeah.
It's like, what? We need an MVP by next Friday. No pressure. So it's like,
Yeah.
where do you start, right? Like, have you worked at Amazon Prime? I haven't, but you might get asked that question. And it's a completely valid one. And I think it's like a ladder of abstraction or like a ladder of uncertainty. The problem begins as an idea with like some thought or business leader or like they see a signal in the market that there's a gap and they say, let's put a product offering in that gap. And then it gets to the product leads and the staff, devs, or the principals. And then from there, it gets shaped up into different teams, and then different teams scheduled into different sprints. And then the junior engineer knows about this really cool buy with Prime button, like in the app. But it's like as you become better as an engineer, you will be exposed to more uncertainty, because that's the
Absolutely.
nature of every problem.
100%. And the thing is, nobody knows. Nobody knows with 100% certainty any outcome. Because if they did, we would be tackling things way, way differently. There is always a hypothesis. Every product manager, every CEO, every business owner knows that there's a hypothesis and it requires trial and error. And this is something that took me, for example, a while to really develop this model. And that's why I always preach to software engineers that they need to understand how the business works if they are working as professional engineers. If you want to go and, I don't know, as what's his name, the creator of C++, talked about in a video. Bjorn, exactly. If you wanna just write code, go play Sudoku, because it's don't be a professional software engineer. Do it as a hobby, do it for fun. But if you want to be a professional software engineer, you have to understand how businesses work, at least if you're ambitious and you want to grow. Otherwise, you can just stay in the lower levels and keep on churning code, get all of the certainty, and everything will be unpacked for you in small tasks, and then you can just keep on churning tickets and closing them and implementing small things. But if you want to deal with the big problems, you have to learn how to deal with this uncertainty. Nobody knows the answer. There's always hypotheses. We test, we try, we get feedback, we go back to the drawing board, we re-implement. That's it. That's how it should go.
Right, 100%. And I like that our conversation has touched on Occam's razor, the scientific method, coming up with hypotheses, testing them, evolutionary process of discovering things. And it made me, I just looked it up. Do you know Wit But Why, the blog?
No, not familiar with it.
It's a really cool blog by a guy called Tim Urban, and he has an article called The Cook and the Chef, which sums up everything we talked about, right? I think
I love it.
Like some engineers are like cooks. They would like to be handed a recipe, and some engineers are like chefs. It's like you give them raw materials and they come up with stuff. But it doesn't apply just to engineers, because he was like talking about Musk. Like regardless if you like your speakers, regardless if you like Musk or not, or agree with him or not, right? Just go ahead and read that article. I think it's awesome.
Love it.
The cook and the chef.
Absolutely. I always use the analogy of recipes, because 100% I agree with this way of thinking. And maybe we need this. Maybe if everybody's a chef, we wouldn't be able to move forward. Maybe. But again, when we create content for folks, we want them to reach their maximum potential. We don't create content so that people stay in their bubbles, right? And then if you want to reach that maximum potential, you try to consume this content. If you want to stay in your bubble, move along. That's totally fine. There's nothing wrong or right in any of this, right? But when we talk about mental models, ways of working, so on and so forth, it's to enrich your experience so that you can get to that next level. And I know it's difficult, because sometimes when we talk about things from a high level perspective, it flies over somebody's head. Because to understand this mental model, it requires a certain buildup of experiences for this model to click and for it to make sense. Otherwise, it's just going to be like okay, what does this actually mean? And it's understandable. So sometimes we try to break it down with examples, but sometimes it's really impossible, and it has to stay in its abstract form, because that's the purest way you can communicate the idea without really stripping it away from its essence. Right.
Yeah.
All right.
100%.
Amazing. Ahmad, this has been an awesome conversation. I would probably go on for hours. Maybe we should do this again and keep on debating or talking about the other aspects of software engineering that are less tangible, let's say.
Yeah.
Because I think that would be an interesting conversation.
They call them soft skills, but I think they are harder than the hard skills themselves.
Absolutely. So the funny thing is, I was talking to Simon Willison. He's the co-creator of Django. And the way we wrapped up the first episode of the season was by him giving advice about what would make software engineers better. And he talked about soft skills. And then he mentioned that he hates this term, soft skills, because there's nothing soft about them. And I think we both agree, or all of us agree that it's probably better to maybe call it professional skills. That's a term I would much rather use than soft skills, because these are the hard skills. This is what I see with my colleagues every day, the stuff that they are fighting with for them to grow and to have more impact and for them to get to the next level.
Yeah, absolutely. And these are the skills that, I mean, you can read about them, but probably I think the best way to learn them is from building things with other people. And I think I read somewhere, it just reminded me of a random quote by Werner Vogels, the CTO of AWS, and he says, there is no compression algorithm for experience. And I think 100% true. Like you just have to go through these examples and these similar stories to learn these skills.
Absolutely. You see, this is one of the things. There's no compression algorithm for experience. If you tweet this, it will literally fly over the heads of so many people. You know, it just takes so much to just understand what this small set of words actually represents and it means. Ahmad, I love this. Any last advice for whoever is listening to us?
Oof, you put me on the spot.
Anything you want to share with them?
Like just adopt be more flexible in the way you design software. Adopt it as an incremental approach. I think a lot of problems could be avoided. Premature optimization happens because people don't adopt incremental approaches. Shipping, just try to ship it. If it breaks, you'll fix it. No worries. You miss 100% of the chances you don't attempt. So just like keep shipping and incrementally improve them. You don't have to get it right the first time.
Love it. That's a great way to wrap up this episode. Thank you very much, everyone, for listening. And thank you, Ahmad, for joining me.
Thanks a lot for having me, Bassam.